Hello everyone, we are Group 10. Today we're gonna give you the final presentation of our project, the CTU Intelligence Entrance System. So in our presentation, I will divide the content into 4 parts. The first part is our objective for the project. And the second is the technical implementation, include hardware and the software. And the third is output and the demonstration. So in this part, we will demonstrate how our project can work. And the fourth is the conclusion, and also we will talk about the future of our project. So for the objective of our project, as you can see, these 2 photos just our entry system between the festival walk and our campus. So you may know, as a student of CTU, you may notice that this entry system is not so efficiency, and sometimes it is lack of security and safety. So our aims is to improve the current entry system between the campus and the festival walk. So let us move on to the technical implementation part. So first, I'll let my teammate Zhang Yachang, who will talk about the hardware connection of our project.
Okay, so thank you, Li Guanyu. And this is the logistic of our project. Firstly, we use an Arduino board to serve as a central controller that receive the data from sensor, like send signal to actuators, and also controlling the cloud parts. And here we have 2 kinds of sensor. One is the infrared sensor, and the other is the RFD sensor, which is to detect motion, like for the infrared sensor, and to read the card tapped for the RFID. And for the actuator, we have a servo motor that to drive to make the door open on either direction. And here we have an alarm, which we will demonstrate later. And here the OLED display will display the name of student and other information. And since we will send the data to the cloud to do a visualization and analysis, so we need to use cloud platform. Like here, we use Arduino IoT Cloud for its low latency. And in order to successfully send the data to the cloud, here we apply a Wi-Fi module. Here is Wi-Fi ESP8266. And this is a logistic of our system. And next, we will show the detail of our hardware configuration. Next slide. So this is the detail of the hardware configuration. On the left is ESP01 module, which is not connected, but I will show it later. And here is the circuit diagram. As you can see that there's Arduino here, and the red is the positive voltage side, and the black is the negative side connecting to the ground. And as you might notice that there is an external 5-volt source, which will, because we need that source to stably drive the servo motor to make it function. And here we also have the 3.3 voltage power supplied by the Arduino board. And beside the red and black lines, here we have some other color line, which means the signal receive or send. Here there are some digital pins on the Arduino that is just to read the data, or just to send out the instruction. Like for the servo motor, it just send out the instruction to open the door to a certain degree. And here also there are some advanced data communication and control protocols, like MOSI, SPI, MISO, etc. So and for the ESP01 module here, because we are using the cloud platform, and our code is relatively large, so we need to so we can separate the code, and we can separate the code that run on the board and that run on the Wi-Fi. So we use the ESP01 to burn the program that's only using the Wi-Fi module into this ESP8266. And such separation can reduce the workload from the Arduino boards. Hence, it will increase the execution efficiency. So this is the hardware configuration.
Okay.
So let's talk about software. Okay.
So for the coding part, actually, how our system work depends on the cases that the system is in. So we divide the status of the system into 4 cases. So the first case is so this state represents the system's idle state. So so this case, in this case, which means the system is waiting for a card to be scanned. And next is the second case. So in this state, the door is opening, and if a person's card is in the UID list, which is in our system, so the door will open. And also in this state, the system will make some choice, or let's say some operations, depends on the input of the components. And also in this state, there will be a lot of tricky things that can manage different cases, and different cases happen. And also yeah, and the third case is the post pass-through processing state. So in this state, the system will initialize some variables and parameters, and go back to the case 0, which is the idle state. Which and in that case, which means the system will waiting for another new card to be scanned. And the last case is for the exception state. So in this state, the system is receiving abnormal informations like unauthorized RFID card, or some abnormal cases happened in the case the second case, and I will talk about it later in our demonstration. And this is the simple flow chart of the program. So you can see it. So this is kind of simple, but actually it's not the full logic of our program. And this part of the coding is what we just mentioned. So this part of the program is for burning to the Wi-Fi module, and we set the things like the going count and the go out count, and also the string for abnormal card number for upload to the cloud services. And also, yeah, and next, let my teammate talk about the cloud interface that we have built.
Okay, so this is the cloud interface that we are building on the left, and on the right is the data fields. Like there are 4 data fields, like there is to record our abnormal card number, to count the people going in, to count the people going out, and there is a prompt message that we will show later. It is intermediate value that calculated by the data analysis. So here, on the left, as you can see on the interface, that there are several boxes. Like on the top left, it records the abnormal card number. On the top right, there are 2 boxes, which is the line chart of the people going in and people going out. It will show the trend of such going in and going out. And below it, on the bottom right, there are 2 set to record the current number of people going in and people going out. And as you may notice that there are also a messenger that it will raise the prompt message. It will raise the prompt message if the people going in is significantly larger than people going out, or the opposite side, then it will raise a warning in the messenger. So this is all for the cloud interface, and next we will demonstrate it.
Okay, so I will share I will let my teammate share the screen and I will demo in the other side. Okay.
Hey, could you please end the sharing first, because I cannot share my screen.
Okay, you can share the screen of the cloud.
Okay, so this is so essentially this is a cloud interface.
Okay, so we're gonna introduce two Lego characters. So she is Lily and he is Jack, and both of them has their authorized car. So first, Lily, the first case is Lily is trying to use her car to go out to campus, and she tap her car and walk through the gate and sensing the second sensor.
And you can notice that the line chart increase, also the number increases.
Yeah. Okay. And the second second case is Lily want to go back to the campus, but actually she decided not to go back to campus. But so in this case, after her tap her card, but she didn't actually enter campus, which means she didn't sense the second sensor. So in that case, the system will not record it as actually enter into campus state. Yeah. Okay, so the third case is Jack is using an unauthorized card want to enter to the campus. So this time the system will cause alarm. And also you can see there are new messages generated in the abnormal card number, which means and this messages is the information of the unauthorized card. Okay. And the next case is more tricky. So suppose Lily is using her card and want to go out to campus, but this guy Jack want to go and enter to the campus, and he wanna go first. So in this case, let's see what happened. So they have her card, but actually Jack sensed the second sensor, and this time the system will regard it as an abnormal cases and start the alarm. So after Jack used his card, and enter to the campus, and the alarm will disappear. And also there are another case that so let's say Jack is just stand at the place that the sensor can be set. So in that case, if Lily want to go out to campus for the safety of Jack, the system will not open the gate for just hurting Jack. Okay. And we also add the data analysis part. So the system will analyze the real-time flow and determine whether there is a significant difference between the number of go into campus and go out to campus. And I will show you just by repeating the number of repeating the action of exit the campus.
And as you can see that there are a few people entering, so currently the message is normal flow.
Let's just wait for a time slot that
Okay, so the new message arises and it says that large flow is entering the campus.
yeah. Okay, so those are the main functions of our system, and that is all for our demonstration. Okay. Okay, so now we are going to give you the conclusion and also talk about the future of our project. So in conclusion, as our proposal, we actually implemented all the functions, let's say basic functions that we write in our proposal. And also we have a more advanced functions, and also we add the part of data analysis, which is really good things happen. And I would like to talk I would like to talk about that our project can not only be used as the entrance system of our campus, like between the campus and the festival walk, but also it can utilize in different cases and different circumstances. Let's say it can be used in the library, and also it can be used in the big event like concert, and also it can be used for the small event that hold by our student community. So for the future plan of our project,
Okay.
so yeah, so you may notice that we only have one authorization method, which is the RFID, but also in the future we can add more advanced authorization method, such as fingerprint and also facial recognition. And also for the data analysis part, we can also use the data we collected and generate more let's say qualified result for the data analysis, and provide more messages to the administrator.
Okay, so I want to mention about three things we need to improve. The first is that we can consider using some more advanced machine learning algorithm to advance our data analysis, and also to help the administrator. For the question on regarding on reading multiple cards, I think that despite improvement can be made on the hardware side, also the software algorithm can be improved. Say, let it read multiple cards within a very short period of time, and then store the value it read, and make a comparison with the authorized UID. And it should not warn immediately if an unseen card is sensed, rather than after reading all cards and then if there is no authorized card, then give a warning. Lastly, I think that maybe we should also consider the limitation from the infrared sensors if we want to put it into real case application. Like for the infrared sensors, like there are some interface between different infrared sensors, and the people from outside the entrance system maybe also be detected. So some hardware or software side should be improved. So this is the improvement can be made.
Okay, so so that is all for our presentation. Hope you like our project. And if you have any questions, please feel free to ask.